Hello and welcome to today's video on why antimatter is so costly. First, let's define what antimatter is. Antimatter is the opposite of regular matter. It consists of particles that have the same mass as regular matter, but with opposite charges. For example, an antielectron, also known as a positron, has the same mass as an electron but a positive charge instead of a negative charge. One of the reasons why antimatter is so expensive is that it is incredibly difficult to produce. When matter and antimatter come into contact, they annihilate each other, releasing a tremendous amount of energy in the process. This is the basis for the idea of antimatter propulsion for space travel, which would be incredibly efficient and fast. However, it also means that antimatter cannot be stored in a container, as it would quickly annihilate any regular matter in the container and cause a catastrophic explosion. To produce antimatter, scientists use particle accelerators to smash particles together and create antimatter particles. This process is incredibly energy intensive, and the cost of producing even a small amount of antimatter is astronomical. In fact, it has been estimated that it costs around $62.5 trillion to produce just 1 gram of antimatter. Another reason why antimatter is so costly is that it is challenging to store and transport. As I mentioned earlier, antimatter cannot be stored in a container, and it requires special magnetic fields to keep it suspended in a vacuum. Any contact with regular matter could cause the antimatter to annihilate, so it must be transported in a vacuum and kept away from any materials that could interact with it. Lastly, there is currently no efficient way to harness the energy released when matter and antimatter annihilate each other. This means that the only real practical use for antimatter is in scientific research, where it is used to study the properties of matter and the universe. In conclusion, antimatter is incredibly costly due to the difficulties in producing, storing, and transporting it. However, it is still a fascinating area of research that could have incredible applications in the future if we can find a way to harness its power. Thanks for watching. Please like and subscribe for more amazing videos.